can have voice commands as well as a motion detection with accelerometer or IMU, all in the same chip at super low power.
Hello IPXers. So we are here at the AONDevices booth at CES 2024, where they're going to talk about a very nuanced and I think complicated solution to what they call voice, sound, and interestingly sensor fusion, and how they put all that together either in an algorithm or in a chip.
Okay, so always on-device AI. So we build a full solution from the algorithms to the chip, as well as a software platform to build use cases and train for different pattern recognition, then load the weights into the chip to execute the use case. Okay, so here we have a few examples of algorithms. One of them is voice command recognition at super low power. So our chip can recognize, for instance, a dozen of voice command at less than 260 microwatts, which is the lowest power chip in the industry for such application. For instance, it can recognize a dozen of sound recognitions as well at less than 260 microwatts. The chip supports a full sensor fusion, which means you can have voice commands as well as a motion detection with accelerometer or IMU, all in the same chip at super low power. Another example of
just pause you there for a minute, because there's a lot going on there, and you've explained a lot of technology, but just explain in terms of application, because so you've got noise as well as what you call this sensor fusion.
Right.
So the chip itself is not just listening for noise and doing that in a low power way, it's also sensing movement.
Correct. So for instance, a use case, we could detect a person falling as well as calling for help. We could detect people snoring. We could detect people presence in a home. For instance, if you want to manage the thermostat, you could turn on the AC when people are present in a home and turn it off when there is nobody in the home. We can do that with sensor fusion, detect, for instance, people presence through their sound, through, for instance, coughing, snoring, any feature basically that is related to human, we can detect with the chip.
Right.
And you don't have to use camera, which are not desirable in a home setting.
Right, and which is an expensive solution as well.
Exactly.
Yeah.
And the big advantage, this is all at the edge, nothing goes to the cloud. It preserves the user privacy as well as the low cost and the low power feature.
Right. So this is using the detection of sound in the same way that you might a camera, but to have the same solution.
Exactly.
Right.
Yeah.
As well as motion, if you were to, for instance, embed that into a wearable.
Exactly. So, for instance, for activity tracking, for like I mentioned, like person falling or any type of motion. Like, for instance, you could even, for instance, for remote control, you could detect the motion of the remote control to control devices, as well as speech. So you can combine speech as well as motion detection.
Right. So if you were to be asked as the CEO of this company, where's the sweetest spot? Because you've got a lot going on there.
Right.
You've got a lot going on. You've got sound, you've got motion, and you've got lots of different varied applications. You could say, oh, we can do that, and oh, we can do that, and oh, we do that too. And you're competing with a lot of different areas all at the same time. So what would be the absolute perfect application if you were going to take all of that into place and say, this is where my chip is always going to be perfect?
Okay, so with AI, since the chip is like an empty brain, you can train it for different application. That's the reason you see these broad applications that you can use, where you can apply this chip. But we see tractions initially mostly in wearable, in headsets,
right?
Even in home automation. Like for instance, as I mentioned, the example of thermostat management, basically for sustainability, power management inside the home.
Right.
Even in leak detection for.
And does that come because of the flexibility?
Exactly. So this is different from the traditional chip and algorithm where it's a fixed function.
Yeah.
This is AI where you can train for different applications.
Right.
So it's applicable to different use cases.
Right. So if because of that, if you like, intuitive AI, all AI is supposed to be intuitive. So, but how would if a design engineer were to come to you and say, I think I've got a problem that you might be able to solve, how does that process work?
So the process work, as you can see here, we have the platform AON360,
Yep.
which supports from data collection, data augmentation, training, and inference simulation. You use this tool first to train for the application. So let's
Right.
say, for instance, you want to detect snoring, okay?
Yep.
You want to detect snoring and turn off TV automatically, right?
Yep.
Then you apply, you collect snoring sounds.
Yeah.
You apply them to this platform, and this platform automatically offer you the augmentation and the training,
Right.
and the weights, which are coefficients, basically software program that comes out of this platform. You load it into the chip.
Yes.
And now you have a chip that detects snoring
Yeah.
automatically, and
Yeah.
you can add action using our RISC-V processor in the chip
Right.
to, for instance, turn off TV or take a
So
different
if I'm a
action.
design engineer, and I mean, as we've discussed, immeasurable number of applications,
Right.
immeasurable subtleties that you might want to
Right.
have to happen. This obviously comes in the form of a software.
Right. So this platform is a software platform
Yeah.
that runs in the cloud, online, or on a PC.
Right.
You train with it.
Right.
You build all your
So do you
use
give that
case.
away for free, or is there a license that they have to pay in order to get hold of
We
it?
have different business models, depending on which business model. But in some cases we give it for free. Some cases we license it to the
Right.
customer.
Right. Okay.
Yeah.
And then if, you know, many types of semiconductor solutions offer many different kinds of solutions, what you're saying is this adaptable algorithm that you run, so it takes in the data, you ask it the things that it's got to look for,
Right.
and then you program it off the back of that, and then you put it on the chip in the application.
Exactly.
That is essentially what you do.
Yes, and the main differentiation between Aon and other companies is the high accuracy at super low power.
Right.
So our chip is the lowest power chip for the number of AI tasks that it performs.
Right.
Like I mentioned, you can have multiple voice command detection as well as sound recognition, all with under
So
260
any
microwatt.
application that is very discrete, where power is vital in AI, full stop, because of the amount of computing that's going on. You're saying that because of the efficiency of how this is going to understand the
Yes.
exact thing that you're after,
Exactly.
it will use the least amount of power.
Exactly.
Good. That's a very good introduction. Just remind me why you called it that.
So always on means a chip that is always on running, 24 hours 7.
Yeah.
And on device AI means everything is running at the edge, no programming goes to the cloud. And basically it's really taken from human nature. We are an always on system where we're always listening, we're always monitoring the system to react.
Yes.
So in the future, we see that robots and any type of machines will be always on listening, always on monitoring, and everything has to happen at the edge for privacy reasons.
Yes. Good. Thank you very much. That's a very good introduction to what you do and how our community can understand how they can get hold of that, apply it to their application, and then see what they can build on it in the very lowest power. Thank you very much.